This video is on geometric series. A geometric series is the sum of the terms of a geometric sequence. The formula to find the sum of a geometric series is S sub n equals a sub 1 times the quantity 1 minus r to the n, all divided over 1 minus r, where a sub 1 is the first term, r is the common ratio, and n is the number of terms. Let's take a look at several examples here. For the first, we're actually given the sequence. So we have 8 plus 2 plus 1/2 plus, we don't know how many are in between, plus 1 over 2048. So let's recall what that formula is. So S sub n is equal to a sub 1 times 1 minus r to the n over 1 minus r. So I need to know a sub 1, r, and n. So a sub 1 is 8. My common ratio, let's take a look at this. So to go from 8 to 2, I have to basically divide by 4, or remember I have to think about what do I have to multiply by. I have to multiply by 1/4, so my common ratio is 1/4. And n, I don't know how many terms are in here because it's just left with this dots in between. So let's go ahead and use the formula a sub n equals a sub 1 times r to the n minus 1 to find our value of n. So I know that my last term is 1 over 2048. I know my first term is 8. I know my common ratio is 1/4, and that's going to be raised to the power of n minus 1, which is what I'm trying to find. So if I divide both sides by 8, which is the same as multiplying by 1/8, I get 1 over, grab your calculator, 16,384, which equals 1/4 to the n minus 1. And I didn't leave myself enough room here, so I'm going to have to slide up here. Now, this is an exponential equation, so I'm going to go ahead and rewrite this as with exponents and raising each side of the equation with the same base. So 1 over 16,384 is the same as 2 to the negative 14th power. And recall that 1/4 is the same as 2 to the negative second. And when I multiply, let's see, I'll go ahead and write that out. 2 to the negative second, and that's raised to the n minus 1 power. So 2 to the negative 14th is the same as 2 to the negative 2n plus 2. And recall that when solving an exponential equation and the bases are the same, I can just pull off the exponents and make those equal to each other. So n is going to be equal to 8. So let's use our formula. So the sum of these first 8 terms is going to be 8 times 1 minus 1/4 to the 8th power over 1 minus 1/4. Okay, this is really going to be taxing our algebra skills here. We can simplify this a little bit. So this is going to be 8 times 1 minus 1/4 to the 8th power is 1 over, don't go to decimals, leave it as fractions, 65,536 over 3/4. We can keep going here, this isn't too bad. Let's go ahead and do the subtraction here. So 8 times, remember 1, I can just write this as 65,536 over 65,536, and subtracting 1 from that gives me 65,535 over 65,536. And instead of dividing by 3/4, I'm going to multiply by 4/3. And believe it or not, that if you clean this up and put this into your calculator, it doesn't end up being a pretty number, but it does end up being a rational number, 21,845 over 2048. So that's the sum of the first 8 terms of that geometric sequence. And as I said, leave it as a fraction, don't turn it into a decimal. Let's take a look at our second example here. I have a sub 1 is 9, r is 1/3, and n is equal to 8. So let's go ahead and I think we have enough information that we can put this right into our formula. So s sub 8 is going to be a sub 1 times 1 minus r to the n over 1 minus r, or 9 times 1 minus 1/3 to the 8th power is 1 over 6,561. Leave it as a fraction, over 2/3. 1 minus 1/3 is 2/3, or 9 times, and again I'm going to think of this 1 as 6,561 over 6,561, and subtracting one of those from it gives me 6,560 over 6,561. And then instead of dividing by 2/3, I'm going to multiply by 3 over 2. And plugging that into my calculator gives me 3,280 over 243. So we're not getting really pretty numbers here, but they are precise and it is working out. Let's take a look at our third example here. Number 3 has a sub 1 is equal to 3, r is equal to 2, and a sub n is equal to 768. So what I don't know here is what n is equal to, so that's what I need to find. So I will use my formula that says a sub n equals a sub 1 times r, whoops, I know that r is 2, to the n minus 1. So using that, I'm going to divide both sides by 3, so that gives me 256 equals 2 to the n minus 1. And again, I have an exponential equation, so I want to write both sides of the equal sign with the same base. So 256 is 2 to the 8th is equal to 2 to the n minus 1. And I can make the exponents equal to each other, so n is going to be equal to 9. Now I can use my formula, so the sum of the first 9 terms is going to be a sub 1 times 1 minus r to the n over 1 minus r. So this time we don't have as many fractions. I think we're just going to end up with some bigger numbers here. So 3 times 1 minus 2 to the 9th is 512 over negative 1, or 3 times negative 511 over negative 1, or that's going to end up being, actually the negative divided by a negative is going to give me a positive, so 3 times 511 is 1,533. And our last example of this type uses the summation notation, the sigma notation. So recall again that the number on the bottom is the first value of k that I will plug into the explicit formula, which is out front here. The number on top is the last value of k that I'll plug in to get my a sub n, and then the explicit formula is what's here. What we need to notice though is that this 2/3 is going to be my r, my common ratio. So a sub 1, when I plug 1 in for k, I have 2/3 to the 0 power. Anything to the 0 power is 1. A sub n, or I'm sorry, let's go with a sub, well, I'll leave it as a sub n, is what I get when I plug 4 into here. So that's going to be 2/3 to the 4 minus 1 power, or to the 3rd power, which gives me 8 over 27. Hold on, let me go back. I don't need a sub n. No, I don't need that. What I do need is r, which is 2/3, and n, which is going to be the number of terms, which is 4 minus 1 plus 1, or 4. So I apologize for that. I don't need to know a sub n for this formula. That was for the arithmetic series formula. So s sub 4 is going to be equal to a sub 1, which is 1, times 1 minus r to the n. I'll go ahead and do some more parentheses here, over 1 minus r. Let's clean that up a little bit. So I'm going to ignore this times 1. So that's going to be 1 minus 2/3 to the 4th power is 16 over 81, because 16 is 2 to the 4th, 81 is 3 to the 4th, over 1/3, or this simplifies to 65 over 81, divided by 1/3 is the same as times 3, or 65 over 27. So again, the summation notation using this sigma looks a little confusing, but we just basically use that to find a sub 1, and in this case r and n, and then plug it into our formula here. So a geometric series can also have an infinite number of terms and still have a finite sum. So the sum of an infinite geometric series is a much simpler formula. S equals a sub 1 over 1 minus r. Notice that there's no subscript n here, because if it's infinite, there is not a set number of terms in the sequence. It's infinite, so we don't have to put anything there. And this is where a sub 1 is the first term, r is the common difference, with the absolute value of r less than 1. So the absolute value of r has to be less than 1 in order for an infinite geometric series to have a sum. If the absolute value of r is greater than or equal to 1, the series does not have a sum. To say that an infinite series has a sum means that it converges to a number as n gets very large. So in other words, as you increase the number of values that are added onto this sequence, it approaches or converges towards a particular number, so we can say that that series does have a sum. If it does not converge to a sum, if it continues to get very, very large, then we say it diverges. And this is going to happen when the absolute value of r is greater than or equal to 1. So let's take a look at a couple examples here. So find the sum of each infinite geometric series if it exists. So here we have 1 plus a negative 1/2 plus 1/4 plus, and so on. So recall that our formula is S equals a sub 1 over 1 minus r. So for this one, a is equal to 1, r is equal to, well, let's see, so what is my r going to be? So if I do negative 1/2 divided by 1, that gives me a negative 1/2. So does that make sense? Do I have to multiply by negative 1/2 each time? It does. And since r is a fraction, I know that this sum does exist. So S is equal to a sub 1 over 1 minus r, or 1 over 3 over 2, or 2/3. So even though this goes on forever, if you were to keep adding, so my next term would be negative 1/8, and then a positive 1/16, and a negative 1/32, it would converge to or end up at the number 2/3. Take a look at our second example here. We have a sub 1 is 1.1, r is 1/10, so this will converge at a particular value. So S is equal to a sub 1 over 1 minus 0.1, 1 over 0.9, which is actually equal to 1.2 repeating. I like to be a little more precise. That's actually equal to 11/9. Next example here, a sub 1 is equal to 1/4 and r is equal to 4. Since the absolute value of r is greater than or equal to 1, this diverges. In other words, this sum is going to keep getting very large and it will have no sum. So in this case, the sum of this series does not exist. And our last example here uses our sigma notation. So for this, a sub 1 is going to be the value that I get when I put the first value of k into here. So k is equal to 1. 1 minus 1 is 0. 1/2 to the 0 power is 1 times 3. So a sub 1 is 3. And my r is my common ratio of 1/2. Since that's less than 1, this does have a sum. So my sum is going to be a sub 1 over 1 minus r or 3 over 1/2, which is the same as 3 times 2, or 6. So in this, unfortunately very long video, we took a look at geometric series. And there are two different types of geometric series. You can have a finite geometric series that ends at a certain number of terms, or an infinite geometric series. And an infinite geometric series can either converge or come to a particular sum, or it's possible that an infinite geometric series would diverge, and it does not. It just keeps getting incredibly large and does not approach a particular number. And we took a look at the formulas for both of those and several examples. One thing I would say is be very careful. Try to keep things in fractions and remember how to use and solve exponential equations.